Hello everyone. Today we, from Group 3, would like to do a presentation on the overview of the Superscalar instruction cycle in the i7 series. The Superscalar architecture is a design that is widely used in modern computers and processors nowadays. Its design, which was first introduced in the early 1990s, is target different kind of market users, such as enterprise-level workloads that needs an advanced parallel processing and large cache for high throughput. Although this architecture can also be used for personal computing tasks such as gaming and media editing. In today's presentation, we would like to discuss about the use of Superscalar architecture and the process that happens inside the Superscalar processor in detail. The Superscalar architecture is used by well-known companies such as Intel to enhance the performance of their processors by enabling them to execute multiple instructions simultaneously within a single clock cycle. This increases the throughput of a processor, making it faster and more efficient at running complex programs and performing tasks. The Superscalar architecture is a design that is widely used in modern processors, and its design, which was first introduced in the early 1990s, is a main feature in the Intel i7 processor series. Dell Alienware Aurora R14 is an example of a computer which uses the Superscalar processor to handle simultaneous gaming and streaming tasks smoothly. It is considered a general-purpose design, but with a specific focus on enhancing performance through instruction-level parallelism, or ILP. The Superscalar architecture is widely applicable, compatible, and well-suited for parallelism. Next, we will be discussing about the process that happens inside the Superscalar processor in detail.
2.0 Superscalar organization. This is the diagram of Superscalar architecture. Superscalar processing refers to the capability of a processor to initiate multiple instructions within a single clock cycle. Superscalar processor achieve this by fetching and decoding several instructions from the instruction stream simultaneously. The instruction cycle, also called the fetch, decode, execute cycle, or simply the fetch execute cycle, is the process the central processing unit (CPU) follows to execute instructions continuously from boot up until the computer shuts down. This cycle consists of 4 stages, which is the fetch stage, the decode stage, execute stage, and store stage.
Next, I'm going to talk about Superscalar organization cycle. First, instruction fetch. In instruction fetch, a collection of instructions, which is many instructions in parallel, are retrieved from the instruction cache. The address computation and the logic for branch prediction make sure the subsequent instruction group to retrieve is accurate, even if the program contains possible branches. Next, instruction buffering. Before being decoded and released, the retrieved instructions are temporarily stored in an instruction buffer. And then, the decode, rename, and dispatch. To determine the types and operand of an instruction, it must be decoded by mapping logical register to physical register, register renaming, reversibility like right after right or read after right has it. This will prevent false dependency from causing pipeline stalls. Instructions that have been decoded are then sent to the instruction windows. Next, instruction windows, for example, queues, reservation stations, and many more. In instruction windows, the available instructions are stored in the instruction windows. The reservation station track when each instruction window operands become available, and the functional units are given instruction with all necessary operands. And then, instruction is switch. When choosing which instruction to execute in parallel, the instruction issue unit takes into account limitations such as resource availability and data dependency. Abbreviated execution units receive the instruction such as integer units for arithmetics, logical operations, and floating points unit for floating point operations. And the execution in parallel and independently, the functional units carry out instruction. For instance, different instructions may be operated on simultaneously by integer and floating points units.
Next, memory access. Instructions that need to access memory communicate with the memory unit. In order to retrieve or write data, load or store instructions, use the memory hierarchy. Last but not least, commit, write bit stage. They are committed to the architectural state after the instructions are finished and the outcomes are confirmed to be accurate, such as sending data back to memory or register. Instruction type determines whether results are returned to memory or register files. To ensure consistency, instructions are retired in the program to preserve the appearance of sequential execution. The conclusion of Superscalar architecture. Superscalar architecture is a way to make processors work faster by allowing them to process multiple instructions at the same time in a single clock cycle. This makes computers and devices more efficient and capable of handling complex tasks quickly. This concept was first introduced in the 1990 and is now a key feature in most modern processors, used in everything from high-performance servers to personal computers and mobile devices. By using several execution units that can handle different tasks at once, superscalar processors speed up the entire process of fetching, decoding, and executing instructions. These designs allow for better parallelism, meaning the processor can work on multiple tasks without waiting for one to finish before starting the next. Superscalar processors are essential for improving the speed and performance of modern CPUs, making them ideal for both personal and business computing needs.
And that concludes our presentation on the overview of the Superscalar architecture in the i7 series. Thank you for listening and have a nice day.